Hello class, this is Dr. Ben. I'd like to work out another problem out of Chapter 4 that was on the second hand-graded homework assignment. And this is problem number 68 that has to do with the speeder and the cop. So I've already started the pictorial representation for this problem, and basically what happens is that the cop is waiting to catch a speeder, and when the speeder passes the cop the very first time they are at the same location, the cop is at rest and the speeder is moving with a speed of v. And the speeder is maintaining a uniform motion, so the speeder's speed never changes, and the cop can accelerate with an acceleration that's equal to a, and when the cop catches up with the speeder, they're again meet at the same location, the final speed of the cop is labeled to be v sub f. And so in the problem, both of the objects, the speeder and the cop, travel the same distance that I have labeled delta x in the same amount of time, because the speeder passes the cop and then the cop catches back up with the speeder. So if we make a list of what we know in this problem, we are allowed to use the sum of the symbols that are given here. There are no numbers. So the uniform speed of the speeder is a known, and the acceleration of the cop is known, and none of the other quantities that are given are known, and what we want to find is what is the final speed of the cop in terms of the quantities that we know. Okay, so we need to use kinematic equations in order to solve this problem, and so we need to be kind of systematic about it. So for the speeder, because there's no acceleration, the only kinematic equation that's really useful is the first one on the list that tells us the final position would be equal to the initial position plus the initial velocity times the time interval. That would be t final minus t original. And we set our coordinate system up so the origin is at the beginning of the problem, and so the initial position of the speeder is 0, and we can set the initial time equal to 0. So therefore we would have that x of f is equal to v times t sub f. All right, and so then for the cop, we can have several different kinematic equations. It probably makes sense, first of all, to write down the kinematic equation for the position of the cop as a function of time. And so that would tell us that x of f equals x of 0 plus v0 times t final minus t original plus 1/2 a times t final minus t original squared. And again, let me cross out the terms that equal 0. So the initial position of the cop is 0, the initial velocity is 0, and the initial time is 0. So that's going to give us that xf is equal to 1/2 a times tf squared. All right, so let me move my paper up, and before we go any further, we can combine those two equations together because the xf terms are the same. So I can set the right-hand sides equal to each other, and I'll change color again. So that would give us v times tf equals 1/2 a times tf squared. And if I would solve this for t sub f, I would get 2 times v divided by a equals t sub f. So that's a nice relationship because it has the two quantities in it that we're allowed to keep in our answer. the velocity and acceleration, and we have the relationship for the time that it takes for this process to occur. All right, so we're asked to find the final speed of the cop, and so the second kinematic equation will give me velocity in terms of acceleration and time. So that would say that Vf equals V original plus the acceleration times Tf minus T original. And I'll cross out the terms that are zero for the cop. Cop starts from rest at time 0, so that gives us that V final equals A times T sub F. So we're not allowed to keep a T sub F in the answer, and so I'm going to substitute from the equation in the box to eliminate T sub F. So that gives me V final equals A times T sub F, which I write as 2 times V over A. And I can see that the A's cancel out in the numerator and denominator, and I'm left with 2 times V. So the conclusion is that the final speed of the cop is going to be equal to 2 times the speed of the speeder in order for the cop to catch the speeder in the same amount of distance. So there we go. That's problem 4.68 from our homework assignment.